Hello everyone, I am Shine and you are watching Civil Engineering Tips channel. Generally, shear walls are used in the lift portions when an architect doesn't allow the columns. While placing the shear wall, we have to follow some guidelines. Don't blindly put the shear wall in the building. If you are putting like that, then your building will get torsion. Here we have 6 models of a building and shear walls are inserted inside the building in different locations. The model of these buildings are same, but the locations of shear walls are different. That's why they behave differently, and for this reason they give different results in displacement and other serviceability parameters. So the behavior of a building depends on the arrangement of the shear walls. In today's video we are going to discuss about the proper location of shear walls. You have to know how to place the shear wall in the building, otherwise your building will get torsion and other difficulties. So let's not waste time and dive into the main tutorial. Poor placement of shear wall. In this figure we can see that there are 2 shear walls available in the building. One is on the top right corner and another one is in the bottom. So if we observe carefully, then we will get to know that lateral stiffness in Y direction is more compared to the lateral stiffness in X direction. At the same time, the stiffness at the corner is higher here. This placement will give torsional effect. In these 2 cases, the lateral stiffness is not distributed uniformly because the shear walls are not placed parallelly. Now let's discuss about the ideal layout of shear wall, and it is the main solution of your problems. You have to remember 2 points inside your mind when you are going to place the shear wall in the building. The first point is shear wall should be placed symmetrically in the plan, and the second point is shear wall should be placed as far away as possible from center of stiffness. The center of stiffness should coincide the center of mass. If the center of stiffness is not coinciding with the center of mass, then there will be torsion. Shear wall should be provided as far away as possible from the center of stiffness. It enhances the torsional stiffness and torsional capacity of shear wall. Here we see 5 shear walls: A, B, C, D and E. A and B are symmetrically placed, but C, D and E are not symmetrically placed. But C, D and E are placed in such a way that the center of mass and center of stiffness are coincided. That's why there is no torsion. When the seismic force is applied in north direction, which is in the Y direction, A and B are going to resist that force. Similar case happens for C, D and E. In both cases, the resultant should be in same line and same point. Even if the shear walls are placed symmetrically, torsion may occur to torsion component in ground motion, and there can be accidental eccentricity in the building. When it is subjected to torsion, then all the walls try to oppose the torsion, and we can see that the torsion resistance will depend upon the force and the distance from the center. So the distance from the center is important, so the lever arm should be as far away as possible.